Right, the last lecture of the exception handling stuff. So the one thing I've been keeping from you is finally, right? I've mentioned it, but we haven't really looked into it. Like I said, I'd show you that code again. We'll keep it simple, but the stream. So the code I showed you before isn't exactly what you would write. You'd actually write this. So we'd say s equals null, and or s is assigned null, and then we'd set s to be new whatever, and we'd use whatever we'd read from it whatever, right? If this is an exception or any of these throw an exception, we'll go to the catch where it'll do whatever information it needs to do, but it won't close the file. It'll do that in finally. So how finally works is if we get into the try, we're guaranteed to get into the finally, barring two cases. We call system exit, which causes a virtual machine to shut down. The other one is that the VM crashes, right? So those are your two choices. Other than that, exception throw in, not throw in, doesn't matter. If you made it into the try, you're guaranteed to make it into finally. Which means even if an exception is thrown and we go to the catch, we're still guaranteed to go into the finally because we made it into the try. So try goes with finally. If you get into here at all, you're guaranteed to get into here. So this way we don't have to have the close here and here. We can just put it in one place. So I don't like repeat and close, right? Before we had the close in here and here, which sucks. Now we can just put the close inside the finally, which is really what that try with resources does. It generates code like this. So that's the use case, but let's see a little bit more about finally, just to see what kind of things you can syntactically do with it. So the rule is, if you have try, it has to be followed by catch. And that can be followed by finally. Okay? It's almost the rule. The rule is actually try can be followed by finally, which is also almost the rule. The rule is you can have try followed by either the word finally or by catch. One of them has to be present. And catch can be followed by finally optionally. Right? So you can just do try finally, and you can do try catch finally. Why would we want to do try finally? A couple of reasons. Let's say some sort of illegal runtime exception gets thrown in here. We'll still hit the finally on our way out, and we'll be able to do whatever actions we want to do here. There's also just that's the primary reason. There are some times, I don't recommend it, but there's some times when you're doing some code, you're going to say if whatever, return, or return one or whatever, and then there's a bunch more code. Putting the code in the finally, it says even if you return from here, it's going to enter the finally block, do the finally stuff before it actually returns from the function. I don't like this because I only want to have one return at the end of my function or my method. So that's my preference. But some people do put returns in various places. Therefore, it does wind up being useful. So finally, in this case, is being used to make sure that something happens if the exception is caught or not. In this case, it's making sure that it gets handled whether or not there's a runtime exception or error, or if you have multiple returns. So those are the two use cases for it. I rarely use it. I, I, I do on occasion use it, but I actually don't have a use case that I in my own code that I have used it because probably it's like once every 4 years or something I find a use for it, but it's pretty rare, which is why I didn't throw it into the main lecture. Um, and this one, the try finally, that's basically been replaced with try with resources. So the most common case was that anyone would use this is already dealt with try with resources. So you won't find much use for this for the most part. That is going to depend on your coding style. There could be people out there that code like this all the time. I don't, but that's a stylistic thing. So I will show you code with both of these after this.
The code for the final part of exception handling. This is going to talk about finally, but it's not. The focus isn't really on finally. It's to show you. It's sort of a consider it to be the big quiz that's not really a quiz, but this time for exception handling. So I'm going to do the same kind of thing I did before. I'm going to have functions and methods. But I'm going to have several of them call one another. You may wonder why I use foo, bar, car, star. Well, they rhyme, but the real reason is that they carry no meaning. So I want you to focus on the structure. If I use like cat and dog and bark and meow and all that, you have a wealth of knowledge that you've built up over years that helps you understand that. What's a foo? What's a bar? Who knows? Right? So I'm going to pass in a boolean for each of these. And that's going to control whether or not the exception happens or not. And I'm going to make each method look like this. Which in retrospect I should have done first and then called them all. Oh, actually I'm going to add this as well. So I'm adding all of these print statements so that we can actually see what goes on in great detail. Okay, so if f is true, I can type. Okay. So I'm going to ask you a question. I'm going to scroll through the code to give you a chance to answer the question. So we're going to start off with this being false, and let's see if you can get the answer. My question is, what's the out? I guess we'll add this here too. So my question is quite simply, what is the output of this code? So I'll scroll through it, so you can start. You can pause it as I do that, and try and figure out what you think the output's going to be when we pass foo, call foo, passing in false. Okay, so let me go take my stab at what the answer is going to be and see if you got it right, and then we'll run it and see. So it's going to print out starting, then we're going to pass in foo with false. So we're going to print out that we entered foo. So starting, entered foo, and we're going to print out before bar. We're going to call bar, which says entered bar before car, which is going to call car. Entered car before star, going to call star. Enter star. And it's false, so we will say we will not throw, and it's going to say that it's leaving star. And then we return back to where we called from, so it's after star, and now we're leaving car. And we're going to print after car, and we're leaving bar. We got one of them right. And then we're going to print out after bar and leaving foo, and we're going to print out ending. Let's see if that's right. So we start, we entered foo before bar, we entered bar before car, we entered car before star, we entered star, we will not throw, we're leaving star, we're after star, we're leaving car, over there. Then we're after car, leaving bar, then we're after bar, leaving foo, and then we're ending. There we go. Now the question is, what happens when we do the same thing, but this is now true? So again, I'll scroll through, you can pause and figure it out. So we're going to start off with starting, and then we're going to call foo, passing in true. Okay, so my answer is, we're starting, we're entering foo before bar, entered bar before car, entered car before star, entered star, will throw, then we throw. And remember, if we make it into the try, we have to make it into the finally. So we're going to print out leaving star. And because this threw the exception, we're going to skip over this, and we're going to say leaving car. And because we threw the exception, it's going to skip over this, and it's going to print out leaving bar. Through here, so it's going to skip over this, and it's going to say leaving foo. And it's going to skip over this, or it's going to exit from this, skip over this, and just crash. It's saying that it had a runtime exception. So it should be a bunch of leavings at the end. Yep. Leaving star, leaving car, leaving boo, leaving far, and foo. And we can click on these, and we can actually see this is that call stack, right? It's a stack. It's one on top of the other. So we started at star, then we went that line, we called that it through, we called that it through, we called that it through. So we can see actually exactly what went wrong. Now, what happens if instead we make this throw an IO exception? We're going to have to come up here and say that it throws an IO exception, which is I'm going to say that this one has to either catch it or throw an IO exception. And then this one is either going to have to catch it or throw an IO exception. Well, let's change this to have catch So I'm going to print cut in car. Okay, so same thing. What's it going to print out? Again, we're going to start off with starting, then we're going to call foo true, and we're going to go down. See if we can work out the answer. Okay, so my answer is we're going to start. We're going to go in entered foo before a bar, entered bar before a car, entered car before star, entered star. We throw an IO exception. It'll do the finally, leaving star, leaving car, caught in car. It'll go from here, skip over this, but we will print out caught in car, and then we'll say leaving bar. Then we'll say leaving foo, and it won't crash. Right? And that's exactly it. Leaving star, leaving car, caught in car, leaving bar, after bar, leaving foo. Ending. Right? Because we caught the exception. Since we caught the exception, it stops dealing with the exception at that point in time. So question is, how do I know when a method should throw the exception and when should a method catch the exception? And there's no really good answer to that. The best answer I have is sort of vague and general and non-satisfying, but it is quite simply you catch it when it's the most appropriate thing for you to do. Okay, how do I know when that is? Well, the general thing then becomes, what is the purpose of the method down here? And I've already told you basically can't catch that. If you threw it in this method, you can't catch it in this method. So this method has to throw. So why did this method choose not to catch it, and this method chose to catch it? Depending on how you're writing your code, this could be in a GUI, and the user presses a button and something bad happens, and you want to report it back to the user. The most sensible place to actually handle that is up in the button handler, and we'll talk about button handlers later on. But there's some code that you write that says, I press this button, do some code. Well, if that code throws the exception, that's where you should catch it and display the result to the user. Another thing is maybe this code here could be used by the command line, so no GUI, or it could be used by the GUI. So it doesn't know, should I pop up a dialog box, or should I log it to a file somewhere, or should I print out a message? It has no idea. So since it has no idea, it can't do anything with it. So it says, I don't know what to do with this. You decide. So whoever called me can decide, right? And then eventually I get caught by this. So if you don't know where the code will be running, it's not safe to deal with presenting a message. My answer, generally speaking, is I want to put my catch as high as possible, usually main. Because probably, and not in all cases, but probably, there's nothing I can do in that case, right? I just want to gracefully exit and say, okay, this didn't work out, and you're going to have to rerun the program in some way. That's not always the case. It's quite often where it's like, okay, if this didn't happen, I expected it not to. Like you couldn't. The file didn't exist, so now I have to go off and create the file, right? So that could be an expected thing. I go to read the file, it's not there, then I'll create it. There could be reasons why I don't want to check to see if the file exists yet. So I have to cope with the fact that the file may not exist, and I have to create a default one sort of thing. Well, that's the kind of code I might write. So that might make sense in that case. So it is highly dependent on the thing that you're using, the way the code you're writing and the way it works. There's no one size fits all answer. We're almost to the point of being able to do an assignment. Yay. We're going to just do one more thing after this, which is unit testing. All your assignments are unit tested, so need to show you that. And the last thing to do with exception handling that I haven't shown you, but goes along with the unit testing, is how to create your own exceptions. So we don't have to limit ourselves to just the exceptions that Java provides. We can create our own. And your assignment will require you to do that. So um, but before we can do an assignment, we'll make sure that you know how to make an exception and unit test for them. But this covers everything except for creating your exceptions. This covers all of the. I believe I covered everything, but it at least covers the important aspects of it. I can't think of anything I left out. There you go.